Here we're going to look at the power of a power rule. So that's where we have something like this situation here, where we've got something in brackets that's already been raised to a power, and then everything in that bracket is being raised again to another power. In order to do this, we're going to need to understand the multiplication rule for powers, which I've written on the right hand side here. So that's where we have the same bases and we have something to the same base raised to one power multiplied by that raised to another power, in which case we add the powers. So I'm going to look at two quick examples where we can deduce what that rule is that we're going to use for power of a power, and then we'll apply that rule in a few examples. So the first couple of examples we will look at are 3 squared, and we're going to raise that to the power of 3. So if we break down what this means, 3 squared in the brackets is being raised to the power of 3. So everything in that bracket is going to be multiplied by itself 3 times. So in other words, we're going to do 3 squared times 3 squared times 3 squared. Now we do know already from our multiplication rule that if we have the same base multiplied over and over again, we can just add the powers to simplify that. So that's going to be 3 to the power of 2 plus 2 plus 2, or more simply, it's going to be 3 to the power of 6. We'll look at a second example. We've got x to the power of 4, and that's being raised to the power of 3. So we'll break it down like we did with the last one. X to the power of 4 multiplied by itself 3 times. And using the multiplication rule, we know we can add the powers. 4 plus 4 plus 4 is just 12. So we can see a pattern here that's already forming. If we're just adding the powers each time and we're writing it out as many times as the second power in our power of a power, what we're really doing is we're just multiplying the powers. Here we put x to the power of 4 times by itself 3 times, so we had to add the 4s to themselves 3 times, which got us our 12. So our rule, our general rule that we're going to follow, is that if we have a to the power of m, all raised to the power of m, then we can simplify that to a to the power of m times n. So that's the general power of a power rule. Before we apply it to any examples, I just want to go through one more, which is this one here, where we've got something else in the brackets. So we're going to have 3x cubed all squared. So instead of just having one thing to the power of 3 all being squared, we'll multiply those powers, but we want to know what to do with that 3. So I'm going to break this one down. 3x cubed times 3x cubed. So we're squaring all of that in the brackets. The 3x cubed is being squared. So if we have a look at that, what we're going to end up with is 3 times 3, or 3 squared, times by x cubed times x cubed. So we'll add the powers, becomes x6, or 9x to the power of 6. So what happens there was the 3 actually also became squared. So everything inside the bracket gets squared or raised to whatever power. So let's do a couple using the rule. I'll do these ones in another colour. So we'll start with 8 squared all to the power of 3. So we're just going to keep the base as it is, because that's what our rule says, and then we're going to multiply the powers 2 times 3, so it's going to be 8 to the power of 6. This second one is with a variable, x to the power of 6 all to the power of 5. So keep the base the same, x, multiply the powers to the power of 30. 2x squared all to the power of 3. So like this third example we did on the left-hand side, we're going to cube the 2. And you don't really need to write this part, but I'll just do it for the sake of the demonstration. And then we're going to multiply the powers on the x. So that's going to become x to the power of 6. 2 cubed is 8, so it'll be 8x to the power of 6. This one's got 2 things inside the brackets, but in this case they are both going to be variables. So what we're going to do is we are going to multiply each of the powers. So we're going to do a to the power of 2 times 4, and we'll do b to the power of 3 times 4. Here we have a number outside of the brackets. So if we have a look at this question here, we've got 10 outside the front, at the front of the brackets, and then we've got m to the power of 5 all squared. So what's going to happen is this m to the power of 5 part is the part that's being squared. The 10 out the front has not had the square applied to it. So it's going to stay as 10, and the part inside the brackets, we are going to multiply the powers. So we're going to get 5 times 2 is 10. So that's 10m to the power of 10. So that's different to if I had this question. Oops. If I had this question where the 10 is inside the brackets, that's a different question because the 10 is inside the brackets, the square is applying to it. So that would end up as 100m to the power of 10. Couple more examples. We have 2 to the power of 3x. So we now have a variable in the power, and that's all raised to the power of 4a. So we're going to keep the base as 2, and we're going to multiply the powers. So 3x times 4a is going to be 12ax, and I'm just writing those in alphabetical order. And one final problem. We've got 3x to the power of 4 inside the brackets, and that's being squared, and we've got that over 10x to the power of 8. So we'll simplify this. We'll square the 3 to get 9, and we'll multiply the powers of the x. 4 2s are 8, and we'll keep the denominator the same for the moment. Now we can see that we now have x to the power of 8 in the numerator and the denominator. So what we can do is we can cancel those 2 terms because they're factors. So we're dividing through by a factor of x to the power of 8, and that's going to simplify to simply 9 over 10.